What is Solana? Solana is a blockchain network that focuses on fast transactions and a high throughput. It uses a unique transaction mechanism that enables very high speeds. Users can pay their transaction fees and interact with smart contracts using the network's own cryptocurrency, SOL. Currently, one of the biggest challenges for blockchain technology is scalability. More and more projects are growing steadily and thus often reach limits in terms of transaction speed and confirmation times. As a result, transaction fees are increasing and transaction times are getting longer. Solana aims to remove these limitations without compromising security or decentralization. Founded in 2017 by Anatoly Yakovenko, the Solana blockchain uses a new method to verify transactions. Bitcoin, Ethereum, and many other projects struggle with their approach in terms of scalability and speed. With the new method, which Solana calls proof of history, the Solana blockchain can process thousands of transactions per second. And we'll take a look at how that works right now. Solana is a third-generation proof-of-stake blockchain. It is based on a unique method to create a trusted system for determining the timing of a transaction called proof of history. Tracking the order of transactions is hugely important with cryptocurrencies. Bitcoin does this by bundling transactions into blocks with specific timestamps. Each node must validate these blocks in consensus with other nodes. However, this process ensures that there is a significant wait for nodes to validate a block over the network. Solana takes a different approach instead, and we'll take a closer look at it right now. Solana transactions are all hashed using the SHA-256 hash function. This function produces a unique output for each input, which is extremely difficult to predict. The output in turn serves as the input for the next hash, and the order of transactions is now built into the hashed output. This hashing process creates a long, unbroken chain of hashed transactions. This feature creates a clear, verifiable sequence of transactions that a validator adds to a block without the need for a traditional timestamp. The hashing also takes a set amount of time to complete, which means that nodes can easily verify how much time has passed. Proof of history is different from the process Bitcoin uses as a part of its proof of work consensus mechanism. In Bitcoin, blocks are large groups of unordered transactions. Each Bitcoin miner adds the time and the date to the block it completes based on its local time. The time may be different or even wrong for other nodes. The nodes then have to figure out if the timestamp is valid. By arranging the transactions in a chain of hashes, the validators process and transmit less information in each block. Using a hashed version of the last state of the transaction significantly reduces the time it takes to validate a new block. It is important to understand that proof of history is not a consensus mechanism like proof of work or proof of stake. Rather, it is a way to reduce the time required to confirm the order of transactions. When combined with proof of stake, selecting the next validator for a block is much easier. Nodes take less time to validate the order of transactions, meaning the network chooses a new validator faster. The Solana team has broadly developed 8 core technical functions to make the blockchain match the capabilities of a decentralized system. Proof of history is perhaps the most notable, but there are others. I will introduce you to a few here. First, there's Turbine, which is a special protocol for blockchain distribution. Then there's Gulfstream, which is a transaction forwarding protocol without a mempool. For example, in Bitcoin, mempool is the place where transactions are waiting that have already been sent but have not yet been recorded in the blockchain. Then there's, for example, C-level, which provides parallel runtimes for smart contracts, and pipelining, which provides validation optimization of a transaction processing unit. These features create a primarily high-performance network that achieves block times of less than half a second and processes thousands of transactions per second. For comparison, Bitcoin's block time is about 10 minutes and Ethereum's is about 15 seconds. Now let's take a quick look at what the SOL token is. SOL is Solana's cryptocurrency that functions as a utility token. Users need to pay SOL to pay transaction fees when they want to make a transaction or interact with smart contracts. Similar to Ethereum, Solana also allows developers to create smart contracts and implement projects based on their blockchain. SOL uses the SPL protocol. SPL is the token standard on the Solana blockchain, just like ERC20 on Ethereum. The SOL token has two main use cases. First of all, paying transaction fees when you use the network or smart contracts, and second of all, the staking of tokens, which is part of the proof of stake consensus mechanism. Anyone can easily stake their SOL tokens without a minimum amount, thus keeping the network running and receiving a reward for doing so. If you want to know how to easily invest in the Solana project, feel free to check out the video description. There I have linked you a video of mine where I show you step by step how to easily buy the SOL token. Also subscribe to the channel to not miss any new videos about cryptocurrencies, and if you have any questions, always feel free to ask them in the comments.